Actually, in 1906, there was a young chemist from, I think he was from Cambridge, and he got the job of his dreams. He was hired as a quality assurance manager. How boring. As a quality assurance manager in Dublin. What is Dublin famous for? Huh?
Guinness.
Guinness! Exactly, you're absolutely right. He was hired as a quality assurance manager in the Guinness brewery. That would be my dream job. I mean, I just let you into a secret. I'm an incredibly cheap date. 1 pint of Guinness is my absolute limit. 2 pints of Guinness, I dance on the table. 3 pints of Guinness, I strip naked and fall off the table. Not good. Anyway, he was offered this job as a quality assurance manager at Guinness Company. And they said, we have a problem. We need to make sure that our product is of the highest possible quality and that the batches don't change. So you are a smart graduate from Cambridge. Come up with an idea for that. By the way, this guy was called Gossett. And of course, he accepted that job. Who wouldn't? And he tried to figure out how he could do that. So they said, for example, we know that all our beer should have alcohol content of, I think, 5.8% volume. Volume per volume. So that is the average. That is basically the population mean of all our Guinness. And we want you now to figure out a way how we can test a large batch or several of the batches, whether they are conforming to this 5.8%. So Gossett went away and said, hey, that's great. I could probably figure out the standard deviation of that. So I have my population mean, and I've got my standard deviation. So I can easily use the normal distribution. I can easily use what we have done before. Of course, one of the other requirements of using the normal distribution is n must be larger than 30. So he said, ha, great, fantastic. So in order to use the standard, the normal distribution, I need to take 30 samples, test all 30 samples, at least 30 samples, and then can use the normal curve. So he took his first sample, he had to test it first. Yeah, it's good. Tested the second sample, yeah, it's good as well. Third sample, it tastes all right. Fourth sample, fifth sample, peace, love, and understanding. 16th sample, he was on the floor. His manager said, gee whiz, we've got an alcoholic. Not good. Okay, Gossett, if you want to keep your job, you're no longer sampling. At least not 16, which was not enough anyway. You have to come up with a better idea. And when he has slept out his hangover, he was sitting down and said, okay, obviously need to do something else. So he developed a statistical test. Statistical test. And he basically said, okay, we have the population mean, but we don't have our population standard deviation, and we don't have N30. So I need to come up with something different. So he said, okay, I take a sample, S1. This sample is characterized by X bar and by the standard deviation. And we try to make a prediction from this sample. We predict from this sample what the population mean actually would be. So we call this mu predict. And then we compare it to the mu from our population that we already know. We basically said, okay, our hypothesis is there is no difference between mu predict, and this prediction comes from the sample, and the mu that is known from our population. So with the sample, I try to make a prediction. What is my population look like? What does my population look like? And that I then compare to the known one. Does that make sense? So far? And that is what we call the null hypothesis. The alternative hypothesis, H1, is it's not the same. Mu predict is unequal to my known, oops, goes downhill. How many pints of Guinness have you had, Peter? It's not the same. It's different. And he found a way how to calculate that. It's a fairly complicated way, which I'm not going to show you, because we've got computer programs that can actually perform this test. However, what I want you to know is the name of this test. Actually, Gossett was so excited that he had developed this test that he went to the owner of the Guinness company, which imaginatively was a Mr. Guinness, and said, I want to publish that. And Guinness said, forget it, mate. Obviously in an Irish accent, which I can't do. Why didn't he want Gossett to publish that? Well, it's just simply because the competition could steal the secret how they measure these things, how they get the same quality time and time again. So Gossett eventually published his test, and he gave himself the pseudonym Student. And this test actually has a name, and it's called the Student Ttest. Why it's called T, we're not entirely sure. It has nothing to do with the tea that you know, the infusion. Anyone here from the Tea Society, by the way? Yeah, we do have a Tea Society. Anyone here? Yeah? Who said yes? Tea Society? No? I was told it's a really great society. What they do is they drink tea, different teas, they try different teas, and eat cake. And I thought, you know, that hugely appeals to me. Sorry? Anyone want to sign up for the Tea Society? Yeah, speak to the union. So this is a student Ttest. And I will email you some videos that show you how you can do this student Ttest in Excel. Don't worry if you won't be asked to do a Ttest in an exam. Yeah? Don't worry about that. Now, a characteristic of a Ttest is that it has a confidence level. Very often is 95%, but not always. And we said alpha in this case would be 0.05. So we have H naught mu predict equals mu known. H1 mu predict is not the same as mu known. And this Ttest basically calculates a probability. It calculates a p-value. And if this p-value is lower than alpha, we reject our null hypothesis. Then we say, and instead of the null hypothesis, we say, instead accept H1. Accept the alternative hypothesis. So if P is low, H naught must go. We reject it. If P is high, H naught can stay. Exactly. Yeah? And basically this Ttest calculates a p-value. Now, it can do this in two different ways. And these two different ways depend on how you formulate your null hypothesis. How you formulate your alternative hypothesis, sorry. mu predict is the same as mu known. We said H1 mu predict is not the same as mu known. This means we have, let's say, our 95%. H naught refers to all the 95% things in here. Predict, and the H1, the alternative hypothesis, in this case, refers to all the things that are not the 95%. So the not is on both sides of the distribution. How many tails does the mouse have in this case? How many? 2. So that would be a T-tail test. If I formulate the alternative hypothesis as H1, you predicted is smaller than mu known, that's again my null hypothesis here. In this case, I'm looking for all the things that are smaller. How many tails does that have? 1. So that would be a one-tailed test. So how many tails we have depends on the alternative hypothesis. Do I say it's not the same? Then I have 2. 2 options, left and right. If I say one of the moose is larger or smaller, then I have only 1 to look at, and I've got 1 tail. Yeah? So, this t-test that we've done, this t-test used 1 sample. 1 sample with 3 basically testing. Or we said we have 1 sample basically consisting of n equals 3 or The important thing is that we have 1 sample here. So therefore we are talking about a t-test with, or rather, 1 sample t-test. 1 sample t-test and we can do 1 or 2 tails, depending on how we feel. Make sense? So I want you to remember that we can have a 1 sample t-test with 1 or 2 tails. Now, the Guinness people said, actually, what happens if we don't know really know our population mean? That's a bit of a pain, isn't it? Because now, if I want to do this, predict known. I can't do that because I don't have a population mean to which I can compare it. Gossett was pleased because he said, oh, we need to do more experiments. And got absolutely rat-assed again. But luckily, he came up with a different way. He said, right, I might not know the population mean. What I do is, actually, I take two samples in this case. Sample 1, standard deviation 1, and sample 2, standard deviation 1, standard deviation 2. From this, I say I can predict, mu1 predict. And from this, I can predict another population mean. And I just simply define one as sort of the known one. So he said, right, my null hypothesis in this case is mu1 predict equals mu2 predict. Just by simply saying, if they are the same, well, I set one as the known one, basically. If they're both the same, shouldn't be a difference. And as the alternative hypothesis, he said mu1 predict is not the same as mu2 predict. If it's not the same, how many tails would we have? Sorry? Think about it. How many tails would we have if it's smaller? If it is not the same, we would have two tails because we are looking at both ends of the curve again. Yeah? So here we would have two tails. Now in this case, again, he was only allowed to sample, to take 3 samples for S1 and 3 samples for S2. It brought him back to 6 pints. For me, I would be clinically dead, but obviously people at my age shouldn't drink anyway. So this is a test, a Ttest, that contains 2 samples. It's a 2-sample, a 2-sample Ttest. We take one sample and another sample and compare them with each other. And again, they can be either one or two-tailed. Depending on two-tailed, or here depending on how I phrase my alternative hypothesis. Yeah? So we have a 1-sample Ttest and we have a 2-sample Ttest. And in the two-sample t-test, the important thing is that S1 and S2, the samples, are totally unrelated to each other. There's no relationship between them. I take basically, is that used? I take basically 3 pints in pub number 1 and drink 3 pints then in pub number 2. So sample from the pub number 1 have nothing to do with the samples from pub number 2. Right? That is what I mean by unrelated. Or there is no connection between them. That make sense? Pretty much. Now people said, wait a moment, this is a fantastic tool here that we have. Maybe we can use that. Because very often we say, right, I have, let's say, a patient or a group of patients who I measure. So sample 1, A1, B1, C1, D1. And then I treat these people. So treatment. For example, I give each one of them a pint of Guinness, and I see how they react. And after they've drunk the pint of Guinness, I measure them again. Now it's A2, B2, C2, D2. Is the person before and after the treatment, is that the same person, same DNA? What do you think? Yeah? So A1 and A2, they are the same, just before and after the treatment. So this is before, after. What about D? Before and after, same person? Pretty much. So what we have here is the samples are related, are very closely related, because they use the same individuals. So samples related. And what I can do in this case, I can say, okay, I get my mu1 predicted here, and my mu2 predicted. And again, I can do a t-test. How many samples would that be? 1 or 2 sample t-test? 1 or 2 sample. Do I know the population mean? No. 1 or 2? Must be a 2 sample t-test. So it's a 2 sample t-test. 2 sample t-test. But now the samples are related to each other. Or we can also say there's always a pair of samples. There's a pair of samples. They need to be paired. And that's why this is called a paired the two-sample paired t-test. A paired t-test measures before and after. Yeah? The calculation is slightly different, but it again, in any case, one sample, two sample paired, two sample unpaired. In any case, I get a p-value. And if this p-value is lower than alpha, p lower than alpha, I reject the null hypothesis. It doesn't matter whether it's for a one-sample or two-sample paired, two-sample unpaired test. It is always, if p is lower than alpha, then I reject the null hypothesis, and I say they come from different tests. Make sense? Here is a big question for you. And then I'll let you go, because I know that was a lot today to take in. I want to compare two samples S1 has n equals 10. S2 has n equals 8. So in the first sample, I measure 10 individuals, or measure 10 data points. In the second sample, I measure 8 data points. What kind of test should I use? How many samples have I got? Two samples. So two sample t-test. Paired or unpaired? Sorry? Who thinks, what's your name? Faven. Faven says unpaired. Who thinks it's unpaired? Hands up. Get a little bit of blood. Okay, who thinks it's paired? Can it be paired? Why not? You're absolutely right, but why are you shaking your head?
There's a different number of participants in each sample.
Exactly. So while the first 8 could be matched, yeah, there are 2 then left in the sample 1. So we can't have a pairing between them. So therefore, it is a 2-sample unpaired test. Unpaired test. Shall I do a one-tailed or two-tailed test? What do you suggest? Who wants to do a one-tailed test? Hands up. Who wants to do a two-tailed test? Hands up. Who wants to go home? Okay, I'll let you think about that. What we should do. By the way, it doesn't matter. It depends on your alternative hypothesis. And now, have a lovely weekend.